Hi, let us understand the purpose of source control system. In any project, whether it is a big data project or application development or maintenance, I'll be developing some application or some sort of a code where I need to maintain the code in a safe location. That is, every change needs to be tracked and every change needs to be approved before that gets into production. So what we do, we use a source control system. There are a number of source control system available. So what it facilitates, it's going to maintain all the changes within the code as a version, and I'll be in a position to go back to whatever the version that I want. I should be in a position to get that specific version, get that code deployed into production. Source control system gives assurance to maintain the changes as well as maintain the history, and it's going to provide ownership on who is making what change and whether that change is approved against what request. So everything, the ownership as well as the changes will be tracked through the source control system. As such, there are two types of source control system, centralized and distributed. As the name suggested, centralized source control system, all the changes will be maintained in a centralized location. Very good example is Subversion. It's very easy and very simple to use. And the next type is distributed, where Git is a very good example, and it's very powerful and more reliable, and it has multiple features. At the same time, it has a very high learning curve. For understanding purpose, let us take example of Git and what are all features available, what we can do with it. As such, what we do, whatever the code that we have, we call it as a repository. So what I will be doing, I'll be having a repository. And the repository can be made available in a local system in any user. Let's say the user 1 is having a repository. And the same copy can be maintained in a centralized location like a server, and another user can also have the same repository. So this is a very good example for distributed source control system, where the copy of each and every code change will be maintained in every user location or the repository. Within the repository, I can create the content, that is the folders and file structure I can create. What happens, every change that I'm making, it keeps on getting built on top of that particular change. Let's say I have a file A and I'm making some changes on top of it. I'm going to add some lines in file A. Only the delta will get stored. Then I'm adding file B. So whatever the change that I'm making, all the delta will be maintained one after the other. Whenever I wanted to have the latest version, it will be applying the changes one after the other and it will be getting the latest version. Let us see with an example. See, initially I have two lines in a file, that is line A and line B, that is version 1. And on top of it, I am adding line C. So at this point of time, if I look at this particular file has line A, B and C. Then I'm making another change that is based on some request. I am deleting line B. So effectively, I do have line A and C. So at this point of time, I'll be having effectively line A and line C because the line B is deleted. Then let's assume I'm adding line D. So effectively, I'll be having line A, C and D. And Git is very sophisticated. Even the changes within a specific line, it should be in a position to merge. So all such changes we can do. Now, let's assume at this point of time, I foresee two requests have originated, that is making some change for request 1 and making some other change for request 2. So two developers will start working. What I'll be doing, I'll be making a branch out of this. So what branch means, from this particular point onwards, the user 1 will be making their own changes, that is add line U1. And the user 2, they will create another branch. They will start working on the other lines. After their changes are tested, verified, they will be merging the changes with the main branch. So this can be visualized like this. So the main branch, we call it as a master. Assume I have a release for change A and change B. So what I'll be doing, I'll be creating two branches. The exact copy of the master, two branches will be forked. And I'll continue to make the change. And once the changes are tested, verified, I'll merge it to the master. I'll make it as a release. And after all the release, all the changes is merged into the master, I'll be making it as a single release and I'll make that particular branch as a master. And Git as such, it has enormous amount of features. This is just a high level information what I can do with Git. Let us see with a small example. There are a number of tools available to work with Git visually. And within Windows, I do have a Git UI, It's a small application. It is provided by Git. I'm going to create a new repository. Let me go ahead and create a new repository. Let me select a folder. So I have selected a folder to create a repository. So locally the repository would get created. So I do have a repository, and this is the location where I have this specific repository. Once the repository is created, it will create a hidden file or a hidden folder called .git. This is where everything would get maintained. Let's assume I am creating a file A. So I do have a file called file A. Let me edit that particular file. Line 1 in file A. I need to inform Git saying I wanted to have this particular file added as a part of the repository. So I need to stage this particular file, that is marking the file to be added into the repository. Now I have a file A. I'm going to add that particular file into the repository. So I have made a change. Now I'm going to create another file, say file B. Let me make the change to this particular file as well. So I have two files. Now at this point of time, I'm going to have all this file added into the repository. So file B, I'll stage it and I'll commit the change. Well, now there is a request to make changes to this particular repository. Let's assume this is in production. There is a request. So I'll create a branch. I'll say this is request for 1. So from the master, a branch called change request 1 will get created. So I am going to work on the current branch change request 1. At the same time, there is another request, change request 2. So from the master, I'll be creating change request 2. So what we have done, I had a master and 2 branch have been created, change request 1 and change request 2. So whatever the changes needs to be done, I'll be using that specific version. So let's assume I'm going to make the change in the change request 2. The current branch is change request 2. I'll be adding a file into that location. Let's say I'm going to add a file called cr2. So this is cr2. I have made a change. I'll be committing this particular change into the cr2. So I'm into the change request 2. Scan the changes, stage the file, commit the changes. Now I have made the changes to the cr2, but I do have a request to be changed for the change request 1. So I don't want the changes that I made for change request 2. So what I'll be doing, I'll be changing the branch. Check out the change request 1. If you remember very carefully, for the change request 1, I did not have the file cr2. So within the folder, the cr2 would not exist. Now I'll make the change for cr1. So I'm going to make the change for cr1. So I have made the change for cr1. So the cr1 is existing. I'll be checking this particular change for cr1. Let me scan it, stage the file and commit the file. So what we have done, we have the file A, the master, and file B. For change request 1, we had a file called cr1, and for change request 2, we had a file called cr2. Now, if all the changes for change request 1, if it is confirmed, I'll be merging it with the master. So the master, I'll be merging the changes from cr1 to the master. Let me go ahead and merge the changes. I'm in change request 1. I can check out the master if I want. What is the status of the master? I can check. So I should have only the file A and B. Now I'll be merging the changes. Merge. So all this happening locally in the repository that I have. I'm going to merge the change request 1 into the master. I have merged the changes. In case if I want, I should be in a position to visualize the changes. So I had from the master, I had change request 1 and change request 2. Now the change request 1 is merged with the master. So we had file A, file B, and change request 1 is merged with the master. Now I'm going to merge the change request 2 also to the master. Let me go ahead and do that. Merge. I'm going to merge the change request 2 to the master. It is merged. So this should give a very clear information. What I did, I had file A, then file B, then I had the branch change request 1 and change request 2. And change request 1, I have merged it into the master. Change request 2 also, I have merged it into the master. At any point of time, if I want to get the version of change request 2, I should be in a position to get it. Check out whatever the version that I want. If I want to get the change request 2, I should be in a position to get it. Now, both changes have been merged. So I should have file A, B, C, change request 1 and change request 2. case if I want to get this specific version, that is change request 2, I can check out. Only the version corresponding to the changes will be visible. So change request to A and B. So this will give me a full control on which version I wanted to work and what change that I am doing, and merging the changes when multiple users are working. It's going to be very easy and controlled. The source control system like Git, Subversion, and n number of source control system are available, and it's going to play a significant role to maintain the version and deploy the right version into the production.